Okay, so next topic in 3D is finding equations of straight lines under different conditions. So first, we are trying to find the equation of a line passing through a given point A with position vector small a and parallel to a given vector B. So this is the vector form. So we will next see the Cartesian form. But before starting, let me tell you one thing. In this video in particular, I'm not going into any details or derivations. I'm simply going to give you the formula straight away so that you can start doing sums. If you are interested in derivations, then I can make a separate video on that. Okay. Okay. So uh, let R be the position vector of any point P on the required line. That is the line whose equation we are required to find. Remember in 2D also we used to take a moving point P with running coordinates hk. Similarly, here in the vector form, instead of running coordinates hk in the Cartesian form, we will take r as a position vector of any point P on the line. So P is a moving point. So for different positions of P, r will have different values. Now, already it is given to me that position vector A, small a and small b, these are given. So the equation of the line is r equal to a plus lambda b, where what is lambda? Lambda is just a real number. So this is the equation of the line. So I told you already that different positions of the point P will give different values of R, and that actually happens for different values of lambda. That means, say for lambda equal to lambda 1, particular value lambda 1, you get a point P1 on the line. Then again for lambda 2, you get another point P2. So since lambda can have infinitely many values, so obviously this equation represents the path of all the infinite points on this line. So that is the locus. Hence, this is the equation of the line. So you will simply memorize it. I'm not going into any details. Okay. Now, so this was the vector form. Now, what will be the corresponding equation in the Cartesian form? So here, what we are trying to do is to find equation of a line passing through a point A. I've kept the naming same A, but this time it is Cartesian, so the coordinates are x1, say y1, z1, and having direction ratios A, B, C. So what is given? The line whose equation we want to find, the DRs of that line are ABC, and it passes through a point A whose coordinates are x1, y1, z1. This is the condition. So this is a given condition. So in that case, so let P with coordinates x, y, z be any point on the line. Then equation of the line is x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Now, please note one thing. Though I am saying it is x minus x1 by A, but this is not division sign. Remember, please remember, this sign is not division sign. It is just a way of writing and saying, not division sign. Why? Because you may have direction ratios 0. Say there is a straight line whose direction ratios are a, b, and 0. So in that case, it will become z minus z1 by 0. And that is, undefined. But it is not actually division. This is just a symbolic way of representing the equation of the line where ABCs are the DRs, whether 0 or not. So this is one thing to note. Another thing is, if you compare A and B, then the given point part is similar in both the cases. There is a little difference between the vector part. That is, in the first case, a vector B was given, whose only job was to give us an idea about the direction of the line whose equation we will find, because it says that the line is parallel to B. That means it gives the direction of the required line. So similarly, in the Cartesian form, the drs of the line are given. We all know that drs give us the direction of the line. So that is why the vector small p has been replaced by drs, ABC. So again, you will memorize this equation and directly plug in the values. Right. Next, what we'll do is, there are only two situations for finding equation of straight line. So this was one situation. The second situation is, so again, I'm naming it 2a, numbering it 2a for the vector form. So this is so what we are given, 2 points are given whose position vectors are a and b respectively. We have to find the equation of a line passing through these 2 points. So we are doing this in the vector form. So again, let P with position vector r. Conventionally, we always take the moving points position vector smaller, and if any points are given, say for capital A we take small a, for B we take small b. So this is a convention. So let P with position vector r be any point on the line. Then the equation of the line is r equal to a plus lambda b minus a, or b plus lambda a minus b, where lambda belongs to 1. You can choose any one of the form and stick to it. Don't keep changing. Okay. So this is the vector form. Now we'll do the corresponding Cartesian form, 2b. So I'm just putting some dots because the language is same. So to find the equation of a line passing through 2 points, say A is x1, y1, z1, and B is x2, y2, z2. Okay. Now let P, x, y, z any point on the line. any point on the line. Let me tell you one thing. In class 11 2D, you have seen that to find equation of a line, we usually, or in not only line, any figure, to find generally locus problem, we used to take let PHK be any point on the line, HK, and then we used to replace HK by XY. But since we are dealing with 3D here, three axes are involved, three coordinates, we don't use HK, we directly take XYZ as the running coordinates of the moving point. Okay. So in this case, the equation of the line will be, so this will be the equation of the line. Okay. Now just note one thing here. Note these quantities. What are they? X2 minus x1, y2 minus y1, and z2 minus z1. They are basically the drs of AB, the line AB. They are the drs. So you can find the drs separately and then substitute also. So this is equation of line through 2 points in the Cartesian form. Now you have only these two situations to find equation of line, unlike so many forms in class 11 2D. Now next topic that we will do is uh, angle between two lines when their equations are given. So 3, to find angle between two lines with given equations. Again, we'll first do the vector form and then the Cartesian form. Right. Now, let the two lines be, say line L1 is R equal to A1 plus lambda B1, where A1 is the position vector of a point on the line and B1 is the vector to which the line is parallel. That is uh, case 1A that we have done. And suppose the second line is R equal to A2 plus, now here be careful, don't take the same constant lambda, because this is a separate line, you must take a different constant. So of course lambda and mu both are just real numbers. Now we want to find angle between these two lines. So if you remember in 2D class 11 also, when we were asked to find the angle between two lines, we always used to find the acute angle putting a modulus sign, and then the corresponding obtuse angle will be simply 180 minus theta. So here also we are going to find the acute angle, right? So then the acute angle theta between L1 and L2 is given by cos theta equal to b1 dot b2 by mod b1 mod b2, and taking a whole mod. Now if you I want to give a similarity with the vector chapter here, just to help you remember the formula. So here you can interpret it like this. Now you have to find equation between L1 and L2. Suppose this is my L1 and this is my L2, right? Now, what are B1 and B2? B1 is parallel to L1. So B1 is something like this, parallel to L1. This is B1. And B2 is parallel to L2. So something like this. This is B2, right? So from the line, you are going to the vector. So when you are asked to find angle between L1, L2, angle between L1 and L2, whether it is acute or obtuse, whatever, angle between L1 and L2 is the same as angle between B1 and B2 because they are parallel to these lines. So from the vector chapter, you know how to find angle between two vectors B1 and B2, and that is precisely this formula, angle between two vectors B1 and B2. So that is how we calculate the angle in the vector form. Now we go to the Cartesian form. So here let the two lines be, say L1 is where you already know from the second part of the theory above what x1, y1, z1, x2, y2, z2, etc., what they mean. So in this case, the acute angle theta between L1 and L2 is given by cos theta equal to E1 E2 plus B1 B2 plus C1 C2 whole divided by root over E1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square, and this whole mode of this. Okay. So again here a similar interpretation can be given. So suppose your this is your L1, this is your L1. Now since the DRs of L1 are A1, B1, C1, A1, B1, C1. So in the vector form, L1 can be represented as L1 can be represented as A1I plus B1J plus C2K. So suppose I call this vector L1, okay, and there is another L2, say like this L2, whose DRs are A2, B2, C2. So L2 in the vector form will be A2I plus B2J plus C2K. So suppose that is L2 vector. So now from the vector chapter, you know, when you are trying to find angle between two vectors L1, L2, then it is cos theta is given by L1 dot L2 by mod L1 into mod L2, right? So that is exactly what is happening here. So if you take these two vectors L1, L2, do the dot product, you will get the numerator, and mod L1, mod L2 will give you the denominator. So that is how. So that this is nothing new actually. What you have done in vector, same thing here. So more or less, this is the first part of the theory that you need. So in the next portion, we'll do some sums. Okay, so let's start with the sums. Sum number 1. Alright, so the question is find the equation of the line in the vector and Cartesian forms, both forms. And the given data is that the line passes through the point 2I minus j plus 4k. So this is the position vector of the point through which the line passes. That means in our formula, what we had taken as small a is this, and it is in the direction of this. That means this is vector b that we had taken in our formula, because this gives the direction of the line that we have to find. So we'll find both the vector and Cartesian forms of this equation, but directly without any derivations, just as we have done the formula. Okay. So first, the vector form. So this line you must always write, let R be the position vector of any point on the line. Then the equation of the line is R equal to A plus lambda B, where lambda is a real number, my A is 2I minus j plus 4k. Okay, I'm not going to put caps on the I, j, k's every time. That slows me down. But you do put it in the exams, because otherwise marks are deducted. Okay, and the vector b is 2I minus j plus 4k. So we simply put it in the equation. So, okay, now what is r? Remember, position vector r in the vector form is equivalent to uh, a point P with coordinates x, y, z. That means in the vector form, it is equivalent to xi plus yj plus zk. So when we, in the vector form, when we say it is a position vector r, if the coordinates of the point, moving point, we take as x, y, z, then from vector chapter you know that the vector position vector of that point P is xi plus yj plus zk. So we replace, we don't need this here, because we are going to keep the equation in the vector form. So we keep r as it is. We'll need that when we do the Cartesian. So I'm not erasing it. So r equal to, let's put the value of a, 2I minus j plus 4k. That's my a, plus lambda. My b is 2I minus j plus 4k. So the sum is done, but just one small step of rearrangement, that is final answer should be written as 2 minus 2 lambda I plus minus 1 minus 2 lambda j plus 4 plus 4 lambda k, or 2 minus 2 lambda I, just take the minus common, 1 plus 2 lambda j plus 4 plus 4 lambda k. And please mention that lambda belongs to R once more in the last step. So this will be the equation. That is, if I put R here, so the final answer is, this is the final answer. Right. Now let's do the same sum in the Cartesian form. Okay. So in the Cartesian form, if you remember, so P xyz is actually any point on the line. Any point on line, the line. Okay. Now, what is my x1, y1, z1? x1, y1, z1 are the coordinates of a point given on the line. Now, here, if you look at the question, the given point is, the given point has the position vector 2i minus j plus 4k. So if the position vector of the point is 2i minus j plus 4k, then definitely the coordinates in the Cartesian form of the same point will be 2, minus 1, 4. That is, this is again from vector chapter, that is just the coefficients of ijk. So you directly identify your x1, y1, z1 from the position vector of the point. Now, what will be the drs? That is, in the denominator you have ABC, drs of the line. So you need the drs of the line. So basically, our line is parallel to this line. Okay. Now, if they, from that, if two vectors are parallel, then their drs are, you can take take the dr same, right? So basically drs are proportional, so we can take them same. So here the vector b is 2i minus j plus 4k. That means the drs of the line along which b vector lies will be 2 minus 1 plus 4, drs of the straight line along b vector. So since our line is parallel to this line, so I can take the drs of our line also as, that is my ABC, I can take 2 minus 1 plus 4. Okay, I think sorry, really, really sorry. This, I gave the same vector in both the it will be direction, this vector will be, this vector will be, I made a small mistake. Uh, I plus 2j minus k. I plus 2j minus k. Really sorry. It's not a small mistake at all. Anyway, so here also we have to make the changes. So our b is I plus 2j minus k. Right. So then the final answer will also change. So this will be, okay, let me erase this entirely and write it again. Uh, so what I'm doing is, let me erase the intermediate step, because you can make out very easily. I'm taking the minus sign out. So let me erase this portion, and then the correct answer will be, right. So it will be 2 plus lambda. Uh, j is minus 1 plus 2 lambda, right? So plus minus 1 plus 2 lambda, and k will be 4 minus lambda, right? 4 minus lambda. Okay, that's it. So here also we have to make a small change with the same vector I've written here. So our b is actually I plus 2j minus k. This is what we. So, yes, coming to the Cartesian form back. So my ABCs will be 1, 2, minus 1. 1, 2, minus 1. Okay. So now that we know our ABCs and x1, so the equation will be, I'm not writing the formula separately, directly plugging in the values. So x minus x1 by 1, y minus minus 1, that is y minus y1 by 2, that is b, equal to z minus 4, z minus z1 by minus 1. So you can keep the answer like this, or you can simply write x minus 2 by 1 equal to y plus 1 by 2 equal to z minus 1, sorry, z minus 4 by minus 1. So one thing is very important here, one thing you have to note here, do not simplify this anymore. This will be your answer. Okay. Now do not try to adjust the minus signs here, because remember, in the standard form of the equation, you should always have this form, that is x minus x1, not the other way around. Y minus y1 and z minus z1. So if you adjust this minus sign, it will become 4 minus z. That is not the standard form. So in that case, it denominator will be plus 1 and your dr will be 1. So that will be wrong answer. So always keep the numerators in this standard form, and then accordingly you will get the ABCs. ABC. So this is very, very important. You must note this. Okay. So now you have this sum completed both in the Cartesian and the vector form. Let's go to next sum. Sum number 2. Find vector and Cartesian equations. Okay, sorry. Let's do this. The Cartesian equation of a line is given: x minus 5 by 3 equal to y plus 4 by 7 equal to z minus 6 by 2. This is given. Find the vector form of the same line. Okay, so that's the equation. That's the sum. Now, for what you do first is look that your Cartesian form is not exactly given in the standard form. So you must first write it in the standard form. Unless you write it in the standard form, you won't get the correct values of x1, y1, z1 and ABC. So let's rewrite this. So x minus x1 by a, no problem. Y minus y1 by b, z minus z1 by c. So once you write it in the standard form, now you know that your x1, y1, z1 is 5, minus 4 and 6. And your direction ratios ABCs are 3, 7 and 2. Right. Now from here we want to go to vector form. Okay. Again, I said I'm not going to go through the elaborate process, just directly will do. Now remember, how do I get the position vector? Now see, this is the point. This is the given point on the line, given point, which we took in the formula as A, whose coordinates are x1, y1, z1. So we want to find, in order to take it to the vector form, we need to find the position vector of this point. So obviously what will happen? The position vector of given point will be, let's name it A. If the coordinates are this, then the position vector will be obviously 5i minus 4j plus 6k, right? So this is a position vector of the point. So we have found A. Now we have to find B. Okay. Now ABCs are direction ratios of the line, and since my vector B is also parallel to this line, so vector B will have the same DRs. So if these are the DRs of vector B, then in the vector form, my B vector will be 3i plus 7j plus 2k. So basically, these DRs, from these DRs, I'll find out the vector B. So now that we have A and B, we can easily write it in the vector form. So if P position vector R be any point on the line, any point on the line, then the required equation will be, we know it is R equal to A plus lambda B. So now if you just plug in the values of A and B and rearrange the terms, the final answer will come as 5 plus 3 lambda I plus minus 4 plus 7 lambda J plus 6 plus 2 lambda K. So that's going to be the final answer, that is R equal to this. So you have converted the Cartesian form to vector form. Okay, so the next sum is find the vector and Cartesian equations of the line passing through 2 points. So first, let us do the vector form. Now these two are the points. Suppose we name them, say this is point A and this is point B. So in the vector form, we know the equation is R equal to A plus lambda B minus A. Okay, so just check it once. Yes, A plus lambda B minus A. Okay, so now we have to identify our A and B. So uh, since my point A has coordinates 3 minus 2 minus 5, that means our position vector of the point A will be 3i minus 2j minus 5k. Right. Now point B is 3 minus 2, 6. That means the position vector B of the point B will be 3i minus 2j plus 6k. So these are my A's and B's. From here only we can write, okay, uh, because we'll need it in the next portion. So I'll write it here only. So for the Cartesian portion, remember this will be my x1, this will be my y1, this will be my z1, and x2, y2, z2 when we do the Cartesian form. Anyway, first let us complete the vector form. So now if we plug in the values, so A plus A is 3i minus 2j minus 5k. Lambda belongs to R, very important, plus lambda B minus A. So if you calculate B minus A, it is 11k. So finally, the answer should be given in the form R equal to 3i minus 2j, and taking the k portions together, minus 5 plus 11k, 11 lambda k. So that's my answer, final answer. Now we go to the Cartesian form. Okay, Cartesian form. So already we have written our x1, y1, z1, x2, y2, z2. Now let us see what will be my or anyway we can put it directly. So the equation will be x minus x1 by x2 minus x1 equal to, so now if you plug in the values, you will get x minus x1 is 3, so it is, and if you calculate x2 minus x1, then it is 0, y minus y1, that is y plus 2, again y2 minus y1 is 0, and z minus z1, that is z plus 5 by 11. Okay, so this is my answer in the partition form. So note here that the drs of the line, the drs, note that drs of the line whose equation we found just now are 0, 0, 11. Okay, it is not division by 0. So that is sum number 3. Now let's go to sum number 4. Find the angle between the lines are equal to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k, and the second line is r equal to 7i minus 6k plus mu into I plus 2j plus 2k. So now let us name this line as L1 and this as L2. Okay, so let theta be the acute angle between L1 and L2. Okay, now we know that our formula is cos theta equal to whole mod dot product of the vectors b1 and b2 by modulus of b1 into modulus of b2. Okay. Now if you look at the data, if you compare this L1, the equation of L1, this is my A and this is my, or rather let me mention as A1, and this is my B1, right? R equal to A plus lambda B form. Similarly, this one is my A2, position vector of this point, and this is B2. So we, from here we know what are our B1 and B2s. So if you now calculate, you know how to calculate dot product. If you calculate this, you will get 19 by 20. So from here, theta equal to cos inverse 19 by 20. So that's my answer. Actually, the sums on 3D are very simple. The theory looks very formidable, but the sums are quite easy and there are not many varieties also. That's the main advantage. Okay. Now next sum number 5. Same type, that is finding angle between two lines, but this time the equations will be given in Cartesian form. Find the angle between Okay. So again, suppose this is my line 1, L1, and this is my line 2, L2. Okay. Now, you can see uh, we have to, okay, first let us write the formula. We know that the formula is that if theta is the acute angle between L1 and L2, then cos theta is given by E1 E2 plus B1 B2 plus C1 C2 whole divided by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. So we need these values A1, A2. Now to get them, remember our lines have to be in the standard form. So first let us convert them to standard form. So for line L1, if we write it in the standard form, it is x minus 0 by 2, y minus 0 by 2, z minus 0 by 1. That means our A1, so A1, A1, the direction ratios of the first line, let us call them A1, B1, C1. These are the direction ratios of L1, and that is equal to, from the equation we just see that is they are 2 to 1. Similarly, direction ratios of L2, which we are denoting by the symbols A2, B2, C2, will be 4, 1, 8. So now we know all the 6 values, A1, AIs and BIs, all the 6 values. So if we now plug in the values and calculate, you will get the value 2 by 3. So from here, your theta is cos inverse 2 by 3. So that's the acute angle that you get. Okay, sum number 6 says that the equations in the Cartesian form of two lines are given. We have to show that two things. First, we have to show that these two lines intersect, and then we have to find the point of intersection. So let us name the first line L1. Now, let us say that we this constant value, the ratios, each of the ratios have a constant value. So let us suppose that value is lambda, say. Of course, lambda is a real number. So now from here, let us find out what is x. So x equal to 3 lambda plus 1, y equal to minus lambda plus 1, and z equal to minus 1 from here, right? Now, what does this represent? Earlier I told you that when you have a Cartesian equation like this, then this value of lambda, this gives different values, different specific values of lambda gives different points on the line. So when I express x, y, z like this in terms of lambda, so basically it means that 3 lambda plus 1 minus lambda plus 1 and minus 1, what does it represent? It represents any general point on L1. This is very, very important. This technique helps in a lot of the sums. So as lambda is a running coordinate, so if you change the values of lambda, you get different specific points on the line. So these three coordinates, in terms of lambda represents any point on the line. So suppose this representations, that is any point on line L1, suppose we call it 1. Now let us find out similarly for L2. X minus 4 by 2, suppose it is beta. Let us take the constant value as beta. Beta belongs to R. So from here again, just like the previous method, my general point will be, or let me write it directly instead of writing this step extra. So that means 2 beta plus 4, 0, 3 beta minus 1. This will represent any general point on L2. So suppose I name it, I number it 2. Right. So now listen very carefully. This is very important. The first one represents any point on L1 and the second one represents any point on L2. Now, if these two lines intersect, then for intersection, say these are L1 and L2, then the point of intersection will be common, that is, it will lie both on L1 and L2. That means this general point on L1, I mean, what I want to say is what is the condition that should be imposed on the blue one and the blue two to get the situation that the lines coincide, I mean, intersect. That means these 2 points must be equal. Only then these two lines can intersect, because the point of intersection will be both on L1 and L2. So that's the idea here, that we forcefully, as if we already know that they intersect at a point, then for that particular point these two coordinates will be same. So we are forcefully imposing that condition. Okay. So if 3 lambda plus 1 minus lambda plus 1 and minus 1, this point is the same as 2 beta plus 4, 0, 3 beta minus 1, that is, I'm forcefully making them equal, then let us see whether we arrive at any contradiction or everything goes smoothly. If everything goes smoothly, that means what I did forcefully is correct, and that will prove that the lines have the lines intersect. Okay. Now, you know, ordered pairs, you know from 2D that if two ordered pairs are equal, then so then their corresponding components are equal. Same theory for here. So equating the corresponding coordinates of the points, we have 3 lambda plus 1 equal to 2 beta plus 4, which on simplification gives uh, 3 lambda minus 2 beta equal to 3. Then minus lambda plus 1 equal to, that is the second one, is equal to 0. So from here we get lambda equal to 1. And the third coordinate is minus 1 equal to 3 beta minus 1. So from here we get beta equal to 0. So please note that we have already got the values of lambda and beta from the last two conditions. Now if I can show that this pair of values of lambda beta also satisfies the other equation, that is 3 lambda minus 2 beta equal to 3, then whatever I have assumed is okay. So this whole portion comes from the equating of the 2 points. Now from here, suppose I name it number 3. So here we write that putting lambda equal to 1 and beta equal to 0 in 3. Let us see whether it satisfies 3 or not. LHS equal to 3 lambda minus 2 beta. So let's put the values. 3 lambda is 3 and 2 beta is 0, 3. That is RHS. So since lambda equal to 1, beta equal to 0 satisfy 3, therefore lines L1 and L2 intersect, because we have imposed the condition of intersection. This is how we do. We find any two general points on the line and then forcefully equate them so that we get point of intersection. And if these two values of lambda beta did not satisfy 3, then our conclusion would have been that they don't intersect. So the first part is done. We have shown that they have intersect. Now the second part, to find the point of intersection, that is very easy, because now we know that uh, this as well as this, they both represent the same point. So either you substitute lambda in the first one or you substitute beta in the second one to get the point of intersection. Okay, so to get the point of intersection, substituting say lambda equal to 1 in 1, the point of intersection is 4, 0, minus 1. Even if I put beta 0 in the second one, then also you see 4, 0, minus 1. So it doesn't matter whether you put the values of lambda or beta. It will give you anyway it will give you the point of intersection. Okay, so the next sum is find the equations of the two lines through the origin which intersect a given line at pi by 3. So first let me try and draw the diagram. So suppose this is the given line. This is the given line. Let us name it say L1. So this line I am naming L1. Now the lines whose equations we have to find are like this. They pass through, both of them pass through origin. Say this is my L2, this is my L3. Suppose this is the origin, and these two lines whose equations we have to find L2, L3, two things are given about them. One, they pass through origin, and second thing is they intersect L1 at pi by 3, angle pi by 3. So this is pi by 3. This is pi by 3. So that means we have to find, so our job is to find equations of L2 and L3. Now, first what we'll do is, first we note that from the given data, dRs of L1 2, 1, 1. So these are the dRs of L1. Suppose we call it A1, B1, C1. Okay. Now, uh, next what we do is we try to find the coordinates of any general point on L1 just by following the process we did in the previous sum. So let x minus 3 by 2 equal to y minus 3 by 1 equal to z by 1 equal to lambda, say. So this means x equal to 2 lambda plus 3, lambda plus 3 and lambda. Um, Sorry. So this implies that this is general point on L1. So this represents these three coordinates represent any point on line L1. So now if I particularly if we want a particular point in L1, suppose I name it P. So for a specific value of lambda, these coordinates will give the coordinates of P. So suppose we could have done the sum with lambda just as we did before, but for better understanding, I'm including this sentence. Suppose for P in particular, lambda equal to say lambda 1. For specific value lambda 1, we get the point P. So the coordinates of P will be 2 lambda 1 plus 3, lambda 1 plus 3 and lambda 1. So we have the coordinates of P. 2 lambda 1 plus 3, lambda 1 plus 3 and lambda 1. Okay. Now we use the formula for angle between two lines. So we are not using L3 at all. We are working with L1 and L2. So since the angle between L1 and L2 is cos pi by 3, so cos, according to formula, cos pi by 3 equal to, since it is an acute angle, okay, now one more thing we have to, because the formula is, okay, let me write the formula. Formula is A1 A2 plus B1 B2 plus C1 C2 by root over of A1 square plus okay, this is the formula. Now we already know what are our A1 B1 C1. Now what will be A2 B2 C2? Obviously they will be the drs of L1. A2 B2 C2 will be the drs of L1, right? Just as the drs of, sorry, L2, A2 B2 C2 will be the drs of L2, and drs of L1 are, we have already written them as 2 1 1. We already know that. So in order to substitute the values, we need to find A2 B2 C2. So let's do that here. So how do I find the drs of L2? We know that if 2 points are given on a line, we have done that in the dr portion. If 2 points are given on the line, then take the difference of the coordinates to get the drs. So I'm here doing it here. drs of L2. 2 points are, which are the 2 points? One is origin, whose coordinates are 0, 0, 0. The other point is P, whose coordinates are this. So 2 lambda 1 plus 3 minus 0, lambda 1 plus 3 minus 0, and so on. So the DRs are basically A2, B2, C2 will be equal to 2 lambda 1 plus 3, lambda 1 plus 3, and lambda 1. So these are my A2, B2, C2. So we are going to plug in the values here. So uh, cos, this is 60, so cos 60 is half, equal to, now if you substitute all the values and do the calculations, I'm not going into the details, it will be 6 lambda 1 plus 9 by root 6 into root over 6 lambda 1 square plus 18 lambda 1 plus 18. Please do the calculations yourselves. Okay. Now if I square it and cross multiply and solve it, then we will get two values of lambda 1 because it will be a quadratic one. So lambda 1 will have minus 1 or minus 2. Actually, why are we getting 2 points? Because we have not considered L3 in my calculation at all. So actually, these two lambda 1s are one from L2 and one for L3. That's why. So basically now if I substitute the values of lambda 1 in here, let me name it 1. So substituting lambda 1 in 1 we'll get, so first let us put minus 1. So then, okay, no, let us substitute for the drs, right? P is this. No, we want actually drs of L2. drs of L2, right? Okay. So we'll substitute it here. Sorry. We'll substitute it here. Number 1. To get the drs of L2. So substituting 1 in 1, drs of L2 will be uh, okay. So drs are, so lambda minus 1. So this is 3 minus 2. So that is 1. Then lambda 1 is minus 1. 3 minus 1, 2. And lambda 1 minus 1. So minus 1. So 1, 2, minus 1. So this is when lambda equal to minus 1. And when lambda equal to minus 2, then the values will be uh, minus 2, minus 4. So it will be minus 1, 1, and minus 2. So we are getting two sets of DRs for L2. So basically one set is for L2, the other for L3. We don't know which one for, because both of them make the same angles. So we will just write the answer in a general form. So now that we know, first let us write the equation of L2. Now we know that L2 passes through the point 0, 0, 0, and the DRs are also known. So the equation, therefore, equation of L2 will be x minus 0 by 1 equal to y minus 0 by 2 equal to z minus 0 by minus 1. Because it passes through origin, that is why 0, 0, 0, the point is 0 this, and the drs are 1 to minus 1. And then equation of L3 will be taking the second set of drs. And equation of L3 also passes through origin. So x minus 0 by minus 1, y minus 0 by 1, z minus 0 by minus 2. So here we have assumed, without loss of generality, we have assumed that this set is for L2 and this set is for L3. Doesn't matter, because while writing the answer, we are not going to mention L2 and L3. So by the final answer, when we write, we will simply write the equations of the two lines are the equations of the two lines are x by 1 equal to y by 2 equal to z by minus 1 and x by minus 1 equal to y by 1 equal to z by minus 2. That's all. So this will be the final answer. The next sum, sum number 8, just to save time, I have done the sum because it is easy also. So you have to, the coordinates of 4 points A, B, C, D are given. You have to find the angle between AB and CD. So what I simply did is, I found the DRs of AB. How to find DRs I have explained in the previous video. So these two are the DRs of the two lines, and then we simply put into the formula, and theta comes 0 degrees. So AB parallel to CD. So that's it. So for the time being, that is for this portion of the theory, I'm going to end the sums here. And in the second part of the video, I will explain the rest of the theory and do the rest of the sums.